This is the third lesson for the circle unit, and we are now focusing on arcs and chords. So the arcs that the chords cut off actually have a lot to do with each other. We're going to go through the notes first, all right? So the note says, in the same circle or in congruent circles, so there's two circles or the same one, two minor arcs are congruent if and only if their corresponding chords are congruent. So here's a chord, AB, and I'm telling you that that is congruent to the chord CD, so they're the same. What does that mean? That means the arc here, AB, is going to be the same as the arc here, CD. Now, these are lengths. These are going to be in degrees, right? Because arc measures are in degrees. So if we do if then, if AB is congruent to CD, then the arcs AB is congruent to arc CD. All right, just keep in mind that this is going to be a numerical answer and this is going to be in degrees, okay? Next one says if one chord is a perpendicular bisector of another chord, then the first one is the diameter. So if one, see this line SQ is a perpendicular, so 90 degrees, bisector, and it cuts TR in two, then SQ is the diameter, okay? And then vice versa. It says if the diameter is perpendicular to that chord, then the diameter bisects the chord and the arc. So if this is a diameter and it is perpendicular to this chord, it not only bisects the chord, it also bisects the arc. So FG here is going to be the same as GD. Okay. Last but not least, in the same circle, two congruent circles, two chords are congruent if and only if they are equal distance from the center. So if AB and CD both have the same distance. Distance is measured in 90-degree angles. So the distance has to be a 90-degree angle. And so that tells me that the two chords are congruent if and only if they're equal distance. So then if AB is congruent to CD, well, if and only if. So that means that AB is congruent to CD both ways, if and only if the distance, this little tiny little distance EF is congruent to EG. Okay, so that's pretty much it. Okay, so now let's go through the notes on the left side. This is the IXL examples, but I do want you to go through some of the notes here because they're actually really helpful. All right, so it says if, take a look at numbers 1, 2, 3 are going to use this circle here, and then 4, 5, 6, 7 going to use this circle. All right, so in order to not confuse this, I'm just going to cover this up so we don't use that. All right, so it says if the arc GH is 100, then what is the arc IJ? Well, the picture tells me that these two chords are the same. That means that the two arcs are the same. So if this is 100, then IJ must also be 100 degrees. And that's it. Nice and simple, right? All right, new problem now. If GI, so GI here is 55, and then HJ is 115, what about GH? This is X. Well, we know that this must be the same. This also must be X. And we also know that a full circle measures 360. So take 55 plus 115. That will give me 170. And then there's two X's. So you take 360 minus 170. That gives me 190. And I got to give it to 2x, so divide by 2. Then each of them equals 95 degrees. Okay? All right, brand new problem. That's why I have to erase all of this. You don't want the old information to confuse you for the new one. Okay? All right, new problem. If measure of IJ is 85 degrees and HJ is 120, then what is GI? This is your X. Well, we know again, because these two chords are the same, then GH here must also be 85 degrees. So 85 plus 85 is 170. 170 plus 120 is 290. We're going to subtract that from 360, so we must have 70 degrees left. Okay? All right, so that's it for that diagram. Okay. Now, new diagram. This one. Okay, here's the diagram, circle A. Find the length of CJ and AK. Okay, so we're looking for CJ. CJ is right here. And AK is right here. Okay, what do you know? We know BC and FG equals 16. So BC. Well, if BC is 16, but you see how there's a perpendicular bisector there. So that means then CJ already, I can figure out CJ is 8. Okay, that's perfect. Now what do I know? I know BC and FG are both 16, so they're the same. That means then this distance here, AK, must be the same as AJ, right? Well, it tells me AJ is 5, so AK must also be 5. Okay. Again, if that's not clear, rewind and try to look at it again. You do need to dissect this picture a little bit more, and sometimes they give you a little bit more in the picture than you really need. Okay? All right. Next picture, next problem. So I gotta erase all these marks I have. Okay. Find measure of BD. So BD, where's BD? BD is right here. Don't know what that is. If CD is 4x and BD is 2x plus 40. Oh, 2x plus 40. Well, based on this picture here, see, this is a diameter because it goes through the center and it is perpendicular. Therefore, based on what we've learned up top, these two chords are the same and these two arcs are the same. So you set them equal to each other. You say 4x equals 2x plus 40. Subtract 2x on both sides. You get 2x equals 40. X must equal 20. Sorry, 30. But what is going on? We do not want x. We actually want measure of arc BD. So you got to plug your 20 back in here. So measure of arc BD equals 2 times 20 plus 40. So it's 40 plus 40. That's 80 degrees. And that's it for number 5. Okay. All right. Again, be in a good habit of erasing and having a brand new problem. Okay. All right. Next one says find GK. We want GK right here. If BC equals FG equals 20. Well, BC and FG are 20. Well, it's not super necessary to have that information, but you know that these two chords are the same, and the first chord got cut in half, right, because of the perpendicular bisector. Therefore, because they're the same and they have the same distance, you can assume that it does the same thing to you. So GK must be half of FG. So GK equals 10. Okay. All right, last one's kind of fun. Last one, you need to use a few ideas here. Okay. So it says AK equals 3. Well, FG equals 8. If FG equals 8, then that means it's 4 on this side and 4 on this side. How do I find AE? Well, AE is a radius. Radius in a circle is the same all around. So I'm going to ask that you take this radius and just swivel it over so that it's right here. Isn't that same AE? So based on the fact that I have now created a Pythagorean triangle, right, a right triangle, we can use Pythagorean theorem and say 3 squared plus 4 squared equals what squared? Or if you know your Pythagorean triple, you know that this hypotenuse is going to be 5. So AE equals 5. Yeah, it's kind of a cool problem. Okay, well, your IXL is actually a little bit more straightforward than that. So let's take a quick look. First one says, what is the length of DG? Well, we see the two congruent arcs. That means the two chords are the same. If one chord is 8, the other must be 8. So DG is 8. And that's it. All right. Next, what is the value of P? Again, they gave you a lot of extra lines here that you really don't need. What you want to focus on is this. BC here, because that's where the arc is, same as ED here, right? So that means 2P must be equal to P plus 19. Okay, so 2P equals P plus 19. Subtract P on both sides, you get P equals 19. And it only wants a value of P, so 19 is my answer. All right, a less confusing problem here. All right, what's the value of T? Same thing, you have your two chords here. The arcs are the same. That means the two chords are the same. T plus 2 must equal to 2T. Subtract T on both sides. T must equal 2. Last but not least, the arcs and diagram are labeled with their measures in degrees. What is the value of P? Again, it gave you a lot of extra information, but what you should catch is here, this is 4. This is also 4. Then that means this arc right here, UV, must be the same as this arc here, XW. So that means 17P must equal 11P plus 18. Subtract 11P on both sides. You get 6P equals 18. P equals 3. Is that what we want, the value of P? Yes. So P equals 3. Okay, when you're done with this, please go ahead and move on to our Excel assignment, U6.